Okay, trig ratios or trigonometric ratios have to deal with similar figures being proportional. And when we talk about trig ratios, we're actually talking about right triangles. And right triangles are similar to each other, and they have special proportions that we use to solve different equations. So let's take a look at a couple right triangles just to make sure that we understand the different pieces of that right triangle. So we have a right triangle here. We'll call it triangle A, B, C. Angle A is my right triangle, and we'll call it sides X, Y, and Z. We know triangle ABC, the right triangle is, or the right angle rather, is A. But let's say I'm interested in relationships that have to do with angle C. Angle C, I want to define the sides as they relate to angle C. If I'm standing here and I look across the triangle, side X is considered the opposite side. It's opposite the side I'm interested in, or the angle I'm interested in. So side X is the opposite side to angle C. Side Y is the hypotenuse. Hypotenuse is always defined as the hypotenuse or the side opposite the right angle. And then side Z is the side adjacent to angle C. Well, let's write that a little bit neater for you to see. Okay. And to angle C. Alright, so if I'm talking about the adjacent side, okay, I want you to take a peek. If I'm standing here at angle C, and like I said, I'm looking across, the opposite side is X. Adjacent means it's a side that is being used to form angle C along with the hypotenuse. So side Y is the hypotenuse, therefore side Z that's helping form angle C is considered the adjacent side. I'm looking here at triangle DEF, and D is my right triangle, and I'm interested in my relationships as they relate to angle F. Here X is opposite, Y is a hypotenuse, and Z is adjacent. Okay. So those are important terms as we look at the table that you find on page 633 of your textbook. And I've written it out here, but I really want you to take a peek at the words here in the third column. The important thing is that we understand we're talking about ratios of the lengths of the sides of a right triangle. Okay? So the sine function of an angle has to do with the relationship of the opposite leg and the hypotenuse. Cosine of an angle has to do with the length of the adjacent side and the hypotenuse. And then the tangent has to do with the opposite side and the adjacent side, that particular ratio. So how would we use these? If I'm asked to find, for example, the sine of E for this particular triangle, okay, and this triangle should be labeled like this. And I've been given all of this information. And my question is, what's the sine of E? Okay, so what it's asking me is, what is the ratio of the side opposite over the hypotenuse? Because if you remember, go back and look at your chart till we get real familiar with this. Sine of angle E is the opposite over the hypotenuse. So if I'm standing here at angle E and I look opposite, that's 9, and my hypotenuse, which is opposite the right angle, is 15. That can get simplified to 3 over 5. So my trig ratio, my sine for angle E is 3/5. Now we can also use this to find missing lengths. So for example, if I have this angle labeled as 35 degrees, I want to find out what the length of the hypotenuse is if I know that the adjacent side is 1.575. Okay. You're going to have a scientific calculator handy. Okay. As you get familiar with these trig functions, you'll remember that sine is opposite over hypotenuse. That's what we looked at over here on this first example. And then over here, we're going to have to figure out which one of those three ratios we need to use. So if we take a look at the figure, let's see what information we're provided with. We are provided with 1.575. This is the side adjacent to the angle measurement that we know. Okay, so adjacent, and we also know, or we don't know, but we're looking for the hypotenuse. So which trig function has to do with the ratio adjacent over hypotenuse? That is the cosine. So the cosine of the 35-degree angle is equal to the adjacent over the hypotenuse. Let's just fill in all the information that we're given. We're given 1.575 for my adjacent side. My hypotenuse is what I'm looking for. The cosine of 35, if I plug that into my calculator, I get the value 0.8192. I've rounded that. Okay, so to solve this, I'm going to multiply both sides by x to get the x out of the denominator. That's 1.575 is equal to 0.8192 and x. And now I'm going to divide both sides of that equation by 0.8192. And I'm left with a value 1.928. 0.923 is equal to x. So my hypotenuse has a length of 1.923. And we're going to take a look at different ways that we can use our calculators to find these ratios, to find the inverse trig ratios, and I also want to show you how to find reciprocals, so when we have problems like this last one, you may not have to do quite as much manipulating.